Hi, I'm Jeff Stuart. How many of you have had experience with CAD or Inventor before? A little bit. Like, how much have you used with it? Like, minimal. To make parts or anything like that, sketches? Okay. So then I guess I can go through that a little bit quicker. Maybe. Okay. I'll just start from the very beginning. My name is Jeff Stuart. I'm a PhD student up at Purdue University. And some of my background, at least working with CAD and everything else, is when I was an undergraduate student, I was working for a company that did structural analysis. So I did a lot of CAD work and also what's called finite element analysis, so structural analysis work, using very similar packages to Inventor. I didn't use Inventor directly except for when I've been involved with first, but I do know Inventor well enough to give you some general background of what it's capable of doing and what some of the tips and tricks are about how you can go about doing stuff to make things easier for you. So this is going to be a very broad overview of the capabilities and what you can do with it. And it's also be kind of informal. I'm going to be going through by hand, showing you some stuff. If you have any questions or you want me to slow down, or I'm doing something that you've already seen before and you want me to skip it, just let me know. I'll be flexible and adjust to what you guys need to know. So, at the very beginning, you guys know what CAD is, right? Do you know what that stands for?
Computer-aided design.
Computer-assisted design, computer-aided design. Roughly speaking, it's using computers and specialized programs on these computers to help us with our design work. Help us take away some of the sweat and trial and error and actually make it more systematic. So that's what all of these, not just Inventor, but all the other ones you may find out there, that's what they're designed to do. So it's very nice to have lots of capabilities. They are used a lot in industry. In fact, pretty much every part nowadays is designed in something like this before it's ever even prototyped by hand. And the point I guess I want to get across is if your team isn't already using CAD heavily, you should, because it will save a lot of time in the long run. And it will save a lot of time. It'll save you finding out the headaches as you're building it because you will have known them because you've already kind of pre-built it in the computer. So anyway, this is the main opening screen of Autodesk Inventor. I'm just going to click on New right now, and I'll start with the simplest part, which is just an I part, or the standard part. Sorry if these are a bit slow, but while this is loading, where are you? What teams are you from?
4787.
4787? Okay, is that here in Chicago?
Yeah, Northside College.
Okay,
Where do you be able to with neon buildings?
okay. Is that also right here in Chicago? Okay, cool, great. So both rookie teams, or this past year was your rookie season?
Yeah.
Okay. Okay, so here we are, the standard beginning screen of any part. And before we get jumping into how to make a part, I want to point out a few things about it. One, right up here at the very top row, you see, let me follow up my mouse, all these different like 3D model, inspect, tools, environments, vault, things like that. Each of these has something about them that's very, very useful. For example, here in the environments, you have different tabs. The one I may get to talk about a bit later is this stress analysis button, which allows you to help predict failure in your parts before you actually build them. And some other things over here, you can, in the inspection area, you can do things like distance, angles, measurements, something like that. So if you put together your robot and you want to find out the distance between a couple of points or the angle between something, you can very easily figure that out. But we'll start with the 3D model. And we'll start by creating this 2D sketch up here. Another option is creating a 3D sketch. That's a bit more advanced and not really necessary right now. So we'll start with just a 2D sketch. And you see this pane pop up where you can choose which plane you want to draw. So you're going to pick one of them right now. And now you see the view has gone into that plane, so we look at just that plane right now. So anything I draw right now will just be solely in this two-dimensional plane. So the first thing I'm going to do is, well, okay. The reason we're using any of this is because we want to design a part in some way. We want to design an arm, a bar, the wheels, the drivetrain, something about it we want to design. And eventually we break it down to the smallest number, the basic parts that we need to design and build that we can then assemble together. And that's something that's really neat about Inventor is you can design individual parts and put them together into an assembly. And when you update those parts, the assembly automatically updates as well. So for right now, I'm just going to be very basic and say, I want to design a box tube of a certain length with some holes in it. Now, this could go on the frame, this could be part of the arm, whatever it is. Cool. So there, I've defined a box. And I'm also going to, I'll start with just this one box. So I have a box. Very easily created. All I did was just click this rectangle screen up here, drag two corners, and I was done. There are other options in there as well. Feel free to explore them. You know, you can do a rectangle 3 different points, so you can have these oddly shaped or tilted rectangles, things like that. But I don't really want that. I just want to focus on this one guy right here. So let me get rid of that. So now I have this box, or this one box that's going to be the outside of my tube. Let me put in, one of the things about this way all CAD packages work really is that you have to add constraints to design. You have to define lengths, distances, angles, etc., etc. So on this one, I actually need to define some of the things so that the inventor knows exactly where this box is and how big it should be. So the first thing I'm going to do is I'm going to click on this coincident constraint up here at the top. Oh, and another nice thing about Inventor is you just hover over a button for a little while, it'll pop down with this context help so that it can give you a little bit of information on what to do with it. So I have this coincident constraint, and I want to basically lock this corner of my rectangle to this point here, the center of my arm. So I just click there, and click on the center, and boom. One thing's in the right place now. Now I gotta do the other one. Here, here. Now notice a couple of things. One, this corner is now lined up with that little point down there. But two, these lines are now purple, which means that they're constrained. Meaning that there's some lock on them that I can't just freely move them around anymore. If I over-constrain them in some way, it could cause an error. So the next step, to make this box, is the dimension, this side to this side. So click on dimension, here. Okay. So now I have a dimension. I'm going to put in 1 inch. Okay, great. Now this box is a bit too big. I can't fit it all on the screen. When I double click the right mouse button, it'll automatically center basically your entire drawing in the screen for you. So that's a really, really neat, useful trick for it. Now, I just need one more dimension on here. This last green one has to go purple, and then I fully dimension away constraint. So I just click on there, click there. I have another constraint. And again, if this is something you guys already know, just tell me to skip ahead. So right here, I've got an initial constraint. And say I want this box to be 1 inch by 1 inch, outer wall. I can just put 1 inch in there. And then now I've got this 1 inch box. Well, that's not necessarily the best way to do it. Because if I want to make this a generic box, well, I always want it to be a square. Anytime I want to update this dimension, say I want this to be 1.5 inches instead. So I can double click on a dimension, pull this up, say 1.5. Now I've got a rectangle. If I want this to go back to being, if I want this to be a square again, click on that one, 1.5 again. There. Now I have a 1.5 inch square rather than a 1 inch square. It's kind of tedious. I don't want to have to do that every time. So the simple answer, one of the nice features about Autodesk Inventor is that it allows you to do what are called dimensional constraints or functional constraints. Sorry, functional constraints. Where basically I can set one of my constraints to be a function of another constraint or another dimension. So if I want this side to always equal this side, I just go in here, press equal, and click on the one I want. So then now I know that this dimension will always be equal to this dimension. And you can kind of see over here this little pop-up, f of x, colon, and then the dimension. That's just to indicate that it's now a function of something else. So that this constraint is dependent on. So now when I change this back to my 1 inch box, now you see the entire thing stays slow, which is good, which is what I want. The next thing I want to do is, because I want it to be a hollow tube, I want to put another shape on the inside of this one so that, you know, there's this hollow space through the middle. I could go back in and draw another rectangle. That'd be very simple and very easy. What I want to do, though, is show a different feature of it. So I'm going to do line instead. So click that line button up here at the top, and then I'm just going to arbitrarily draw in some weird polygon. Four-sided polygon is not a square, not a rectangle, it's not, you've got right angles. But it's there, and I can now work with it. So you can kind of freestyle what you want to do, and then add in the constraints later. So for example, on this, I want to make this now a square or a rectangle, so you can make sure all of these sides behave a certain way. So I can go up here and pick, actually, sorry, parallel constraint. So one of the big things about rectangles and squares have parallel sides. So this needs to be parallel to that. There you go. Parallel dimension, they're not parallel. This has to be parallel to that. Okay. Okay. That already exists. That's another thing about Inventor. If it pops up with something like that, you know, a little warning sign, hey, that already exists, don't try and do that again. Lesson learned, I won't do it again. So now, I want to bring this back to being, you know, kind of in the same orientation as this square here. So, I pick off my horizontal constraint here, click on that guy, and now this thing is horizontal. I pick off, if I want these angles to now be straight up and down, pick off vertical, and boom, vertical. So now I have this rectangle, a bit more tediously than I had before, but you can kind of see the applications if I want to do some odder shaped thing. If, for example, I want to do an L-shaped bracket, I can go through and make this weird shape into a nice little L-shaped bracket and make it into something else. Okay, so now I have this other box, this green box, but it's not inside, it's not going to allow me to make an actual tube. So this is where some more of the nice things come in. So I can string from here to here. And we'll just call you, we'll say it's a 16th of an inch. So 0.0625. You can put in whatever number you want, it doesn't really matter that much. And now I'm going to add these other dimensions as I go along. Except I want this to be all the same wall thickness. So I'm going to use equality constraints on all of these. Make every single one of them equal to this. That. Okay, so now I have everything the way I think it should be, except it's not behaving. You can see how this dimension here, basically this wall is sticking out, so it's no longer, boxes, it's something else, and this is not going to behave well when I try to make a solid piece out of it. There's lots of things I can do to fix this. Probably one of the simplest ones is pick this constraint, right click on this constraint, and then there we go, delete it. And now this line is green again. I can drag it in and out. So I can drag it on the inside and add in a dimension here. Set it equal to this guy. And then now I have the right shape. I have a box inside of a box, and I can use that to make a solid piece. Because that's really what we're going to get to with all of this, is we're trying to make solid pieces out there, representing tubes, wheels, motors, whatever you need to make to put on your robot. And another thing is, that was one way I knew to fix it. There are many, many other ways of fixing it. I'm not going to go into all of them. You're going to have to explore a little bit to figure out what works best, what you're comfortable with doing. Because Inventor gives you a lot of capabilities, and a lot of those capabilities overlap. And so you'll kind of develop your own style of doing CAD work. This just happens to be mine. Okay, so I have these two boxes, and I want to make it into a tube, a hollow tube. I don't need any more here on this two-dimensional sketch, so I'm just going to go up here and click Finish Sketch. And now you see I'm back in this isometric view where I can see my sketch. It's still just a sketch, but I can kind of see it in 3 dimensions. And I'm sure you'll discover these things as you go along, little tips and tricks. If you scroll with your mouse wheel, you can zoom in and out. Do that. Click under the right mouse button, you can move stuff around. It's really helpful when you're getting into doing assemblies and parts. So anyway, here I got this thing. Now I want to make a tube out. And just as with everything else, Inventor gives you lots of options for making 3-dimensional objects. The simplest one to make a tube is this extruded option. What you can kind of see in this diagram here is you take a sketch and you just extend it in 1 dimension into a 3-dimensional object. That's what I'm going to do there. Now you see it kind of projecting out and showing what this tube is going to look like. And I can go in and say, let's make this 12 inches. So now I have this 1 foot long, 1 inch by 1 inch box, 16th inch walls. So that's great. This is awesome. I've got a tube. I'm going to save it. 2. Please be more descriptive when you're making your own parts. And I'll get into this a little bit. Good engineering practice is to be as descriptive as possible with what you're doing. So this is my standard. So say, I like this, but I want to make something similar to it. Maybe I want also 1/8 of an inch walls. So I can now go back in. See this model browser here over on the side that allows you to look at lots of different things you've got going on. This is the extrusion, that big long piece I just made. If I go back in here to the sketch, you see it pop up way back here. And I can go in, right click and edit the sketch. So now let's say I also want something that's 1/8 of an inch. Click on that. 1.25. Now it says 1/8 of an inch wall thickness. So I go, click finish sketch, and Inventor thinks for a little while, and then now you see these things are a bit thicker, right? So I may need to save this for later, so I'm just going to go click save. I should actually go up here, save as. Let's go to 1, 8, 12. So this is a naming convention I just made up myself, but now looking at the name of this part, I know it's a tube. Actually, let's be a bit more descriptive. Square tube, 1/8 inch thick walls. Good. Now I know exactly, without even having to open it up, what that part is about. And that's probably one of the very important practices as you're doing this is being able to document what you're doing, being able to know what you're doing just by looking at names of files and things. So please be as descriptive as possible when you're making these things so that when other people work with you on it or when somebody a year or 2 from now looks at it, they can figure out what's going on. Okay, so now I've got this tube. It's got walls 1/8 of an inch thick. Now, if I want to attach this to the rest of my robot somehow, I need to have something in there that allows me to fasten it on. The simplest thing, and something that Inventor does pretty well, is allow us to put it in holes. So I just have a hole button up here. And this little dialog box pops up and allows me to decide where I want this hole and how big it is and some of the other parameters of it. So, say I want this hole to be on this surface here. So let's click on that surface. You see how it's now highlighted. After a while, if I hover over it, Inventor pops up with all the options I can choose by hovering over that point. So I'll choose this space, put the hole right there. And Inventor, as best it can, tries to put that hole about where I put my mouse click. So now let's say I kind of want to have a better control over where this actually is. So I say I want it to be a certain distance from the end of the tube. You see that popped up? I just clicked on that little edge right down there, and that popped up. And say I want that to be 1.5 inches from the end of the tube. Now you see it pop up. Oh. Finished it too early. Okay, so I accidentally hit enter, right click, and go back and I'll edit this feature some more. So I have one position of it kind of fixed. I know it's always going to be 1 inch from that end. I also want to make sure I can control how far across, right? I don't want to try and drill a hole where it can't even possibly exist, or I don't want to drill through one of the sidewalls. So I want to try and put this right in the middle. So click this reference 2 here, say,
I got a question.
yeah,
Is that 1.5 from the edge of the hole or from the middle of the hole?
from the middle of the hole.
Middle.
They will traditionally do things from the middle of the hole. There are some ways you can set it up to do something different, but this is from the middle. Okay, so I have this dimension in here. And that's all great. I can, so this is my 1-inch box, I can put in 1/2 inch. And you can see it's now moved a little bit, and it's now right in the middle. Well, that's not exactly robust in the sense that, I mean, this hole is 1 inch away from this edge, but if I change how big my box is, if I make it 1.5 inches now, it's always going to be 1/2 inch from this wall. It's not going to be in the middle of the box, but I want it in the middle of the box. So, this is another nice example of where our equations are useful. And as I said, there's multiple ways you can do anything. One of the nice things is if you remember the dimension names, this one I know happens to be D0. D0. Okay, so now it's saying always be whatever this length is, always be that. And now you see the hole is kind of right on the side of it, not where I want it, right? So, 0 divided by 2, that's always right in the middle. That's great. And then there's some other options you can do with this. You know, you can make it a through hole, you can do things like having countersinks and everything else. I'll let you explore those as you need to, but the simplest one right now is we'll just have a hole and go with that. Okay, great. And this hole goes through everything. So you can see now there's this hole that goes through and you can see everything. You know, it's kind of confusing right now because it's gray on gray. So I'm going to actually go up here, and then I'm going to do something right now that's not going to be exactly apparent as to why I'm doing it until later, but it'll be important. So up here at the very top, you can set some properties of this material. For example, I want this bar to be made out of aluminum. So I go up, pick aluminum. Now this thing is made out of aluminum. But I'm not exactly happy with the color still. So even though I know it's aluminum, we go in and pick something else out. Let's go with red. Okay. So even though I know this is aluminum, I want it to look red, just so it's easier to see what's going on. There, it's red. Okay. Oh, sorry, another thing I've been playing around with up here and haven't explained very much. This is like a little navigation square that you can use to drag around, look and see different views. And you can click there to see different views. So anyway, now I've got this. That's pretty hard to see for you, isn't it? This red thing. Sure, let's make it look like rust. No. It's an old part, whatever. So now I have this part. Looks however I want it to be, made out of whatever material I want it to be. I'm going to have this hole. And just to prove that it will always stay in the middle, let's go back to the sketch. I'm going to edit him. I'm going to change this guy. Set it 3 inches. 3-inch box. There's the sketch. Update some stuff. Boom. It's a much bigger box. But that hole that I set is still right there in the middle. Let's fix it, make it back 1 inch again. There's one more thing about this that I forgot to say. So I'll right click on this model browser, again, go to edit feature. The one thing I forgot to set, or explicitly say I wanted to do, was make this a 1/4 inch hole. So that's this little dimension right here. So it's a 1/4 inch hole. So now it's great. I've got this bar with a hole in it. I want to do more though. I want to add a pattern of holes. So I don't just want this one hole. I want holes all down the length. So I go up and I click pattern up here. I can choose whatever feature I want to have pattern. And this rectangular pattern block shows up here. There are other types of patterns. There's circular, there's a few other ones. This is the one because I just want to go along a straight line. I'll do rectangular. And so I've got this feature, this hole I want to pattern. And I need to pick a direction I want it to go. So I'm just going to pick it off of this edge here and say, go along that edge. And now you see this little green guy here. That's indicating where the next hole is going to be once I click OK. I don't want it to be there, I want it to be the other direction. So I can do this flip direction button right here, and now it's going the other way. And I can play around with how many I want. Say I want to have 5 holes. You see 5 there. And then I want to be spaced 2 inches apart. Okay, so 5 holes 2 inches apart. I'll call that good right now. So now I have this tube with some holes in it that I can use to hold on to the rest of my robot. Maybe this is going to be part of an arm or something. So, got all this. Right now I'm just going to save it as it is. Then the next part of what I want to do is actually explicitly model the fasteners. I want to design in CAD the bolts that will be used to bolt this onto the rest of the robot. So, let's go back, create a new part. Okay, so I'm back here at the beginning. Create a new sketch. Pick this face again. So now I'm going to go back and use these lines again. And it doesn't look like it, but this is going to become our goal. So another feature is you can pick individual points off of these two. So if I want to get this point to line up again, coincident, there, this whole thing is done. Just make it look a little bit more ship-shape. This guy's parallel to that guy. This guy parallel to it. Okay. That should have the parallel up. Already exists. That parallel. There we go. Okay, so all of these different sides are parallel. Not exactly great, but I can work with it. So he becomes horizontal. All of them become horizontal. Get them vertical, they all become vertical. So now, I kind of have to know ahead of time how I'm going to build the part, which will help me build the sketch. For right now, I know I'm going to make a revolution out of this one. So I want it to be a certain size. I'm going to go in 0.126 just to prove a point later. So I got that. That's 0.126 from here to here. And then from here to here, I want that to be 1/10 of an inch. Here to here, 1/10 of an inch. So this is going to be like the little flange that holds the bolt on and everything else. So now I have a couple of options about how I want to constrain this last surface here. And if I want to design the bolt using this stuff, I wanted to be able to design it so that I can change whatever length I want it to be, which I can do. But I also wanted to be able, these dimensions to be meaningful in a way. So I want to design it so that maybe I want to directly change the length of the actual bolt that can go through material. So I'm coming to dimension here to here, so I know, the bolt will go attach, hit some surface here, and then go on through it. And I want to know that's going to be, let's say, 2 inches. So now I got this fairly long bolt. And I know that's going to go through whatever material I have. So, good, great. I finished my sketch. I think it's all good. And now we'll see if I actually did it right, because I want to revolve this surface. So, go up here and hit the revolve thing. The nice thing about the revolve function is that basically it allows you to do cylinders or cylindrical objects, like say a bolt. All I got to do is pick out one of the edges I need to revolve around, or some line to revolve around. It doesn't necessarily have to be on the part. If I wanted to, I could create a line over here somewhere and revolve around that, and then I'll have a bolt with a hole in the middle, which actually do come in handy every once in a while. So anyway, I've got the solid bolt. Looks like that, looks good, I like it. Click OK. There, so now I have a bolt. And I want to go in and I want to say this is going to be a steel bolt. Okay? Don't like the way it looks. I want to go nicer, so it's polished steel. Okay. Bolts. Go 1/4 inch, 2 inches long. Okay, so now I have this bolt that I'm going to use to attach my other thing together. So now we get to the really fun part of Inventor, where you can start doing assemblies. This is where it's very, very useful for when you're doing robot design. So you have all these individual parts that you're going to build. You can also see how they're going to go together before you even build them, just to make sure it actually works the way you think it will. And a slight aside, I'm not going to be able to get to it today, but another very useful function here is this creating a drawing. So I can take any of these parts that I have and create a drawing from it, so that somebody in the shop, I can just hand them this drawing and say, build this for me, and it will have all the dimensions and everything else correct, so that they know what to do very quickly. So I'm going to go to the assembly part right here, create extended assembly. Now here it pops up, blank little thing, except if you notice, look carefully, you can see the stuff up here is different than it is for a part. Now I got to see, create sketch, boxes, put in holes, etc., make patterns. In assembly, I have different options. I have place, and create. You can create something from scratch and in the assembly. Lots of other things you can do. Adjust the parameters, make it build the materials. That's actually very, very useful. If you design your robot in CAD, you can just click Bill of Materials and it will pop up with all the things that you used to make your robot. So rather than having to go through and figure it out by hand, you've got this right here for you, ready to go. So anyway, I've got these parts already and I want to put them together. So I'm going to go place, find, here we go, a square tube with 1 inch dimensions. And then there you see one pop up, and you actually see multiple ones. I can add a second one, or however many I want to my assembly. Really, I only want one right now. So I've got my tube that looks kind of rusty. It's made out of aluminum. I don't know why it's rusty, but there it is. So now I've also got these bolts I want to put in. Okay, here, so I've got a bolt, I've got a tube. I want to put them together so that it actually makes sense, so that it can approximate how I actually put a bolt through this particular part. So many, many ways to do that. And again, you can also make patterns of the parts and everything up here. But when I want to constrain two parts together, I go to this constraint box up here, and it will allow me to constrain parts. So anyway, let's say the first thing I want to do is I want the top of this bolt to lie on the top of this surface here. So the bolt's going to go from the top down through this thing. So I'm going to pick the type of constraint that will allow me to do that. That's this mate function here. Basically make two surfaces touch each other. Pick this surface here, you can kind of see that little arrow sticking up. That. And now this other one here, you can see the arrow sticking up there. And now you can see that bolt is on that surface. It's going to stay that way. Just to show you what the other one, this other option does, there's mate, which is surface to surface. There's also flush, which is looking parallel. That's not what I want, but it can be useful in other applications. But here, I've got this surface to surface. These bolts are here. All good. I've got another constraint. Actually, before I talk about the constraints, I want to point out. So I have this bolt here, and it's going to stay on the surface, but it doesn't really stay. If I want to be lined up with this bolt, it's not going to stay there. It's going to move around, be able to be free and move around. It's not what I want. So I want to introduce another constraint to make this line up with one of these things. You can see if I hover over it, I get this option to choose the axis. Choose the axis of this. Here I can see axis there, choose that. Now I know I've got this bolt, I can try and grab it and move it, and it's not doing anything. Now it actually kind of is, it's spinning around in there, but I don't care. The point is, it's not moving out. It's in that hole, and it's going to stay in that hole. I can kind of be around and say, okay, great, I designed this right, it's just sticking at the bottom the way it should be, et cetera, et cetera. Great. So I've got this very, very simple assembly. I'm sure as you're designing your robots or making your robots, you'll have much more complicated things than this. I want to show a few maybe less commonly known features that can really help you predict and solve problems before you even have to build anything. One of those things is viewing the estimated mass and everything else. First off, if I click on that, so I can right click on the tube over here. Down at the very bottom, you see this I properties. So click on that. Then it comes up below saying like who made it, when it was made, when it was last modified, what project you're going to go to. If I estimate it's going to cost $1, you can say that. It costs $1. The way over here on the far side is this physical tab, where I have all these things. I have the density because it shows that it's made out of aluminum. I've got mass, area, volume, center of gravity, moments of inertia, if you're concerned about those. I click, but none of them are filled in. They're all NA, not empty. I actually want to get some estimate as to how much this will weigh. Click update, there we go. It's going to be about half a pound mass. It's got a certain volume, a certain area. It's got these moments of inertia. Great. So now I have an estimated mass for this part. So close on that. I'm going to do the same thing for the bolt. Got properties, physical, it's made out of steel, it got some density, so update it and tell me how much it is. Okay, now I've got some small mass for this bolt too, but it adds up over time. So if I put in every single bolt I'm going to expect to use, I can actually estimate the weight of all of those bolts. The other nice thing is, when I go to assembly, you see this I have properties tab here too. Click on that, go over to physical, and you see that it's already got all of this stuff filled in. It's got mass, it's got area, it's got volume, it's got moments of inertia. But I didn't ever tell it to do it with assembly. It just automatically did it. And if you notice, this mass here is the sum of the mass of the tube I made as well as the bolt I made. So, without ever having built anything, I know approximately how much this is going to weigh. Which is really great when you're trying to design a 120-pound robot and you cannot go over 120 pounds. So before you even build anything at all, you're already you have a good estimate of how much these things are going to weigh. And you can play around with things. If I use aluminum bolts, how much weight do I save? If I make this out of a 16th inch rather than 1/8 inch, do I save? All of that. So that's one very useful thing to know about. The other one is, it's going to be over in this, notice I pointed out this ahead of time, the assembly design. There's also this inspect again where you can, as before you can do distances and angles, but now you can also do things like analyze interference and say, well, is there going to be a problem? Is some part going to hit another part that I don't want that to happen? So I'm going to click on that. I'm going to click on one part, this tube, and say, is there interference between this tube and this bolt? Go OK. And you see now, maybe, I hope, is these two little red green looking things right here? That's telling me that there's interference between the two parts. I made something wrong and there's overlap. If I actually try and do it exactly to the specifications I have here, it's going to be wrong. So I already kind of know what I did wrong because I did it wrong on purpose, but this can help you identify problems. If you have a massive robot and you're trying to figure out whether it will all actually fit together, this can really help you out and figure out the problem areas too. It can also help you to figure out if you want to work on a robot, you can put in a model of somebody, like you can put in a drill or something and say, I want to be able to drill a hole in here, will that interfere with any of the parts that are currently on the robot? Things like that. Think outside the box when you have these tools because they can be very useful. So anyway, okay. I figured out there's a problem, I want to fix it. I have this bolt, I have these constraints on it, but I can't really change much about the bolt directly. But, as I said before, I can go back to my original bolt file, say this is just the bolt, the part file for the bolt. Here, I'm going to change my sketch, edit the sketch, and instead of making it wrong, I'm going to make it right. So now it's going to exactly be a 1/4 inch bolt. Sketch, simple update, save you guys. I should, hopefully, come back here, analyze for interference, and have it work. See, there you go. No interference is detected. So, now I know that I have a working part, and this will actually go together, cause problems. And it also illustrates another point that I said, but didn't really talk about too much, in that I can make a change to this part here, and it will affect what happens there in the main assembly as well. So it's really nice to know that you can go in and correct a part, and every single time you have this part in here, it'll fix it for that part, for all of them. If I have 100 volts and they're all wrong, I go back and I fix just one of them, they're all right. So, and we have about 5 minutes. So let me see if I can.
Change this, let's change that.
Okay. So now, one useful thing that kind of relates to what I'll be talking about in the next session is stress analysis, where I can kind of predict if there's going to be a failure or something. I'm not going to discuss it too much, other than to say it can be very useful. It can help you predict what's going on. I highly encourage you to read into it, but be careful about how you use it. To really be able to do good work with it, you have to have studied some engineering and have some basic idea of the principles of it. But I should definitely use it. If you're curious about it, investigate it and use it. Just take it with some caution, be conservative. Okay, so I got this part. I create the simulation, set some of the parameters of the simulation. I'm going to add some constraints and say this surface is fixed. Okay. Let's see. Okay. Got the force given the surface. We'll say to 10 pounds. Okay, so now I've got a force on here, and I want to see what happens. And just for the sake of doing this, it may take a little while to run. Like I said, this is advanced material right now. I'm just showing it to you so you know the capability, know that the inventor can do these things for you and help you out. While this is running, do you guys have any questions? Anything I didn't cover that you have a question about? No? Okay. Well, we're out of time. This is going to take a while to run, so I'm just going to cancel it. But there are lots and lots of things built into Inventor that can help you. I highly encourage you over the summer and the fall to really start playing around with it and investigate it, because it will help you when it comes back to the spring and you're in the middle of build season and trying to make rapid changes to your road. So, with that, if you guys have any questions you would ask? Yeah.
So are there libraries of common first parts that?
Yes, there are. There are lots of libraries of first parts. A lot of them you can't really modify very well. And that they're just a fixed part, certain shape, and you can't modify the geometry or set properties on there or anything like that.
Do you know how to use this thing?
So, yes, they exist. You'll find a lot of them on Cheap Delphi or in other sources. I think there are some, if you buy from AndyMark, they pretty much always have a CAD model of whatever you're buying from them that you can put into your robot. So yes, they exist out there. Some of them may be useful. Some of them you may want to play around with and create your own so that you have more control about how they actually look in the end. Good question. Any other questions? No? Okay, good. Well, thank you for coming. Hope you got something from it.